Imagine two abysses of the universe drifting toward each other with a quiet inevitability. As if the cosmos itself is holding its breath. On one side stands Ton 618, a blue-white quasar burning with the light of entire galaxies, compressed into a single impossible point. On the other stands Phoenix A, the greatest engine of energy humanity has ever discovered. A cosmic furnace whose power overwhelms everything we think we understand. And now picture the unthinkable moment when these ancient giants no longer glide past each other in silence, but lock on to the same trajectory. Their destinies bend, their shadows fuse, and in that moment stretch thin across eternity. The universe watches in a hush that feels almost expectant, as if aware that a rare black swan of the cosmos is about to unfold. Are you ready to listen? When two black holes draw near, the universe does not respond with the violence we associate with planets colliding. Instead, space itself begins to twist, as if an invisible hand is wringing reality like a cloth. The gravitational pull grows so intense that light stretches thin, pulled into long, trembling threads. Photons lose their straight paths and bend into vast luminous rings that ripple around the approaching giants. Time near the center slows until a single minute can outlive years unfolding elsewhere. As if the universe is unwilling to let this moment pass too quickly, and beneath it all, gravitational waves begin to fracture the cosmic fabric, sending tremors across millions of light years. From distant telescopes, everything blurs into one haunting image. A region of space being torn open like black silk, caught between two ancient gods. And this is only the beginning. We have witnessed black holes merging before. Faint tremors captured by LIGO as spacetime quivered like distant thunder. The first was GW150914. The moment when two black holes of 29 and 36 solar masses collided and forever changed our understanding of the universe. Then came events like GW170814, where three observatories watched two dark stars spiral into each other, and GW190521, the most massive merger ever recorded, creating a newborn black hole of 142 solar masses. Each of these encounters felt monumental to us, yet even the greatest among them is insignificant compared to the scale of what Ton 618 and Phoenix A carry within their gravitational hearts. Ton 618 holds the mass of 36 billion suns, while Phoenix A towers above it with nearly 100 billion. And when giants of this magnitude drift toward the point of no return, the very structure of physics begins to falter. Space-time twists into forms no simulation can capture. Their accretion disks ignite brighter than any quasar ever observed, unleashing spirals of X-rays, gamma fire, and rivers of superheated plasma stretching for millions of light years. The combined radiance could outshine entire galaxy clusters, turning a corner of the cosmos into a lighthouse forged from impossible light. And then, in the span of a single cosmic breath, that brilliance collapses into darkness, extinguished as abruptly as a candle crushed between unseen fingers. But that fading light is only the warning sign for the greatest eruption the universe is capable of creating. If this merger were ever to occur, the first thing to break would not be a star or a galaxy, but the instruments we built to listen to the universe. Observatories like LIGO, Virgo, and Cagra would be overwhelmed instantly. Their detectors drowned beneath a tidal wave of gravitational energy far beyond anything they were designed to withstand. The amplitude of the waves would be so immense that space itself would stretch and compress between galaxies, pulsing to a rhythm set by two collapsing giants. A single surge could travel billions of light years, shaking the cosmic web like a vast silent drum. In the instant of the final collision, the energy released would reach nearly 10 to the power of 60 joules, a number so colossal it rivals the combined output of every star currently burning across the observable universe. A black hole merger does not make sound. Yet, if the fabric of space-time could carry a voice, this would be the thunderstorm to end all storms. A roar that would ripple across eternity without ever making a noise. And at the heart of that silent thunder lies the birth of something darker than darkness itself. When the merger reaches its final breath, what emerges is not merely a larger black hole, but a new cosmic entity forged from the collapse of two ancient giants. Its mass would settle somewhere between 130 and 135 billion suns, a weight so immense that numbers begin to lose their meaning. Its event horizon would expand into a sphere large enough to swallow the solar system hundreds of times over, a boundary where even the fastest photons are dragged inward and erased without leaving a whisper of their existence. Around this monstrosity, gravitational lensing would twist the light of distant galaxies into warped halos, bending space-time into shapes that defy every intuition humanity has ever had. It would stand as a point of absolute darkness, a region where no reflection, no echo, no flicker of light can return to witness its presence. The space surrounding it would transform into a gravitational desert, where stars are stretched into luminous threads, and rivers of matter spiral inward like cascading waterfalls of broken starlight. Among all objects the universe has birthed, this would be the most massive, the most dominant, the most ancient in nature's hierarchy of shadows. But the question that lingers is simple and terrifying. Could such a monster ever truly exist? Or is it only a beautiful nightmare whispered by the laws of physics? Could such a collision truly happen? Or is it simply a theoretical mirage painted at the edge of cosmology? In principle, yes. If the galaxies hosting TON 618 and Phoenix A were ever to collide, but the universe rarely grants us such perfect catastrophes. In reality, these two giants sit billions of light years apart, anchored in entirely different regions of the cosmic web. They do not share a galaxy cluster. They do not share a gravitational well. And with the universe continuing to expand, they drift farther from each other with every passing moment. Carried away by a cosmic tide no force can presently oppose. Under conditions like these, the probability of a meeting in the lifetime of humanity is essentially zero. Yet the universe plays a long game. One measured not in millions of years, but in trillions. If dark energy were to weaken in the far future, if expansion slowed and began to reverse, If galaxies gradually fell back toward a single gravitational center, then even the most distant titans could one day find themselves drawn onto intersecting paths. In a universe old enough, patient enough, and strange enough, the impossible does not remain impossible forever. And if that day ever comes, the cosmos will no longer resemble the universe we think we know. If TON 618 and Phoenix A were ever to collide, the aftermath would be far greater than the union of two black holes. It would be a rewriting of the cosmic blueprint itself. A moment when space-time is forced to redraw its own boundaries. Galaxies in the surrounding region would feel the shift first. Their orbits tugged into new patterns by a gravity well so immense it challenges the idea of stability. Entire stretches of the universe spanning millions of light years would dim into regions of absolute darkness. Places where even the memory of light cannot survive. And in the silence that follows, one question would linger above everything else. A question without an answer. A question older than the darkness it describes. Is there any limit to the power of shadow? The universe doesn't warn us. It simply reveals the truth. One monster at a time.